As sir will permit, then we will start, sir. Start. Sir, shall we start, sir?
Yes, sure, please.
Yes, Indu ma'am.
Good afternoon, sir. Good afternoon, dear participants. I welcome expert of the session, Professor K.S. Sangwa. Sir is working as professor at Department of Mechanical Engineering at BITS Pilani. And Sir did his PhD from BITS Pilani, MTech and BTech from Punjab Engineering College. His areas of interest is sustainable manufacturing, lean manufacturing, integrated and green sustainable supply chain management, cellular manufacturing system, resource efficiency in machining and designing of manufacturing system. Prof did more than 12 research projects. Sir is presently working on geometric tolerancing and precision measurement skill enhancement project. Professor Sagma has supervised 20 PhDs and one postdoc. He is member of many professional societies and conducted many conferences as well. I welcome you, sir, and we are very thankful to you for accepting our invitation for being expert in this FDP. And I request you to share your wisdom with us, sir.
Thank you very much, Dr. Indu, for your kind introduction. First of all, I'm sorry for little delay in the start of the session. It's because of technology. So I hope, can you hear me?
Yes, yes, sir.
Okay. So before technology, so let's go through the innovative product design and development. First of all, I would like to share with you something like what is product development and what is happening in the Indian market at least. So this time, all students, which was in manufacturing system, design, masters as well as undergraduate, they are having more than 2 jobs. So I was placement officer back to last year. So I asked the placement manager, what is this time, how everybody is getting 2 jobs or more than 2 jobs? Then he narrated that there is a product development, product manager job profile, which has come into the market for the freshers. And they are paying something like 30 lakh, 40 lakh rupees. So I asked him, how come this product manager used to be a job profile after 2 or 3 years? Then he told that, sir, there are so many new product design jobs in the market because of COVID and because of the relationship with the China and the delay in the chips. So almost every company is fresh with so many new product ideas that they want the new fresh engineers to be the product managers with 30, 40 lakh rupees. So that's product design and development. What you have to do. But it's little bit, so let's go through how to be innovative product design and developer. So this is what we'll do, what to develop, technology as curve, who should design the product development time, Carnot diagram, product function, how to convert customer needs into technical requirements, concept engineering, how to design for sustainability. That's all. Starting with what to develop, before that, how to develop. What should be the development process? There are traditional development methods which takes longer time and which may not be cost effective in the long run. So there is a new product development methodology known as concurrent engineering. So CE, short for concurrent engineering definition. What is concurrent engineering? It's a systematic management technique used for product development, which provides an integrated approach to the design of products and their related process. So it's not only the design of product, but the related processes also. We'll discuss more about this related processes from the concept to the disposal of the product. So when you design a new product, You think of the product you are designing from the concept to the disposal of the product. How the product will be designed, how the product will be developed, how the product will be manufactured, how the product will be transferred, how the product will be used, how the product will be serviced, what will be the warranty cost, that is the reliability of the product, and finally how the product will be disassembled and disposed of at the end of life. All these things. The various elements of product life cycle like manufacturability, assemblability, testability, serviceability, reliability, quality, cost, disposability, user requirement, etc. are incorporated during the product development phase. They are not thought afterward. They are thought of during the product conceptual design. So that's a new way of developing a product. So that is called concurrent engineering. Let's see why concurrent engineering. What is problem with the traditional development method? So you have a product life cycle, total product life cycle. You can see 2W. Like if I thought of a product today, introduction of product, then it will mature in the market, it will grow in the market, and finally any product has to be withdrawn. Whether you take any product, whether any mobile product or even your car, Maruti 800 also finally to be withdrawn. So 2W can be different. It can be like a year for, like for example, for Apple products. It can be 2 year, it can be maybe 4-5 years for cars these days. So this is the product life cycle. This is market window. So we assume that half of the product life cycle, there is a upward trend. There is a growth in the revenue generation by the product marketing, and other half still we have profitable revenue generation, but generally there will be slight deterioration in the revenue generation. So this is a model by a famous researcher, that if we introduce the product like here at this point, then during this W, this will be the revenue generated. This will be the growth in revenue, and this will be the during the W. So this area under the curve, that is the green one, is the revenue generated. If there is a delay of some time, if you are unable to introduce the product in time D, there will be a delay, and because of this delay, the red area will be the revenue generated later on. You see the red area and green area, there's a lot of difference between the green and red area. And this is defined as like loss in the profit, which is equal to D. D is the delay into 3W minus D divided by 2W square. It's a 2W square. So there is a huge drop in the profit. Or there will be the cost escalation, both way. Okay. So products should be developed and launched as far as possible, well within the time. Otherwise, there will be a lot of revenue generation. Then product development time. So how this product development time can be reduced? If say this is the product development time starting from this point to this point, okay, in some unit, and say assume that these are some of the product, those who are in the design, they know that these are some of the activities in the product design, product development. That is, one is the requirement, the customer requirement, what customer actually wants from the product or in the product. So the marketing department has to get those requirements. So that is, it will take some time. Then engineering design, once these requirements are available, the engineers or the designers, they will design a new product which will be satisfying the customer requirements identified by the marketing department. Then they will hand over to the manufacturing department. So the manufacturing department will develop, they will develop the tools and dies, fixtures, etc. And then finally they will test the product. Once the test is okay, they will go into the actual production, live production of the product. So that's the time required. what if we make some of these activities simultaneously? Like requirement, it can be enlarged even to a more time, like this much, by the marketing department. At the same time, let the engineering department also start the engineer concurrently. That is why the name concurrent engineering, concurrently or simultaneously. And similarly, the process development, they start the process development, then prototype testing will start testing, and finally production. But how is that possible? That's possible only if all the departments work together as a team. So concurrent engineering or simultaneous engineering, as the name implies, means working as a cross-functional team in which we will have the people or the experts from the marketing department, from the engineering design department, from the product development team, from the testing, prototyping, and production department, and accounts, finance, everybody. And they will work together. They will pass the requirements to each other beforehand. Of course, they are still working, like customer market department, they will immediately pass some of the information which they think is the mature information to the design department. Rest of the, they are still finalizing, but they will start on the some mature information design department. So thereby they save this much time, saving in product development time. And if you save the product development time, then you generate more revenue and your product will be successful. So product development time is an important factor for the success of a product. So it's a product thinking. You have to think of a cross-functional team. This is also called the simultaneous or concurrent engineering. And this is over-the-wall engineering. Some of them called over-the-wall engineering. Something like marketing department will take its time, then throw the ball over to the engineering department. Yes, we have these requirements. Please go ahead and develop a product so that we can sell in the market. Then design person, they will have a look at the marketing. Oh no, this is not possible. We don't have this material in India or even our this thing. Please refine your requirements. So they will throw it back at them. They will revise, then they will throw them again. This is the revised, then they will say, oh no, 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 no. This the specific and required, the surface finish required is too much and the cost will be very high. They will throw it back. So it will keep on going. Similarly, it will keep on going between them. This is called over the wall. And that is why there is a lot of time wastage here in this. And here everybody is sitting together. There is no ego. And all of them, cross-functional team, will take a decision together. Okay. What is the basic principles of concurrent engineering? If you want this, then start all tasks as early as possible. All tasks means whether the customer requirement, whether the engineering design, whether the product development, whether the testing, or whether the production, as early as possible. We are not saying as quickly, as early as possible. Utilize all relevant information as early as possible. Fortunately, these days we can have a centralized data or information where everybody can share the information from every department. What is going in the other department? If I am a design engineer, I know that I can search in the Google and find out what are the new material available in my company. And companies are also very big. We don't know what is the new manufacturing technique. Do we have the laser manufacturing? Do we have this 3D printing? All these facilities anywhere in my company or somewhere else. All information is possible. Utilize all relevant information as early as possible. Work structuring, it allows them the work structure together. Who will do what and other things, like module wise. It helps to design the product in the modules, and modules can be developed independently. Everyone participate in defining the objective of the work. That's most important. All of you, if you are the working professional students, the most important thing, knowledge is not important. Agreement of everyone to achieve the objectives is more important. If you take a decision, I will do this, there will be 20 people who will say, who told you to this? Who asked you to do this? Why you are doing this? He must be having some vested interest in this. And same thing you do, but you ask them, can we do this? What should we do? You ask the other people, hello, we have to do something, we have to do some work. Can somebody tell me how to do this work? Nobody will answer definitely. But if you tell, we have to do this and I am doing like this, then everybody will question it. That's why ask everyone. There is a cross-functional team. Everybody will be responsible for defining the objective of the product, so that later on nobody say anything. Operational understanding is achieved in all relevant information. So I leave for the time being. All operational understanding is very easy to take, understand, because these objectives which we defined here, we know, each one in the team know how these decisions were taken. So the operational understanding is very easy. If they go back into the department, for example, some decision is taken for maintenance. That maintenance life will increase from warranty from 1 year to 3 years. Maintenance head will say, why this 3 years? Who will do this? You know, my workload will increase 3 times. Then if the person who is in the maintenance person who is in the cross-functional team to take a decision, he or she will explain, no, this is necessary because we have seen our competitor Y, which is eating into our market segment. He will take over if we will not provide. He has provided 2 years free service. We have to provide 3 years to beat the competition. So that's how operational understanding is easy to get. These are some basic principles. A strong commitment is made to adhere to the decision taken earlier. That's very important. Whatever decision once taken, we have to adhere to those decisions. Decisions are made in a single trade-off space. So all decisions are taken together, not between me and he and somebody else, then X and Y, Y and Y2, Y3 and Y4 and Y, not that way. All decision makers are together. Trust among teammates, because we know we are transparent in decision making, and I will explain why everybody is transparent in decision making. The team strives for consensus. There is a consensus. It may not be always. Design is a compromise. If somebody has to compromise, but there is a consensus even in compromise. Team should be empowered to take the decision, honor of the team. So it's important that teams should be empowered to take decisions. If you don't empower the teams, that may be a reverse may happen, that the cross-functional teams may be highly dysfunctional then. The team uses a visible concurrent process, which we will discuss, consistency of purpose. So there is an objective identified earlier. Everyone is working for that objective. Then, okay, already discussed. Product development. Oh, sorry. So, repentance, okay. Then benefits of the product, benefits from concurrent engineering. So reduction in the time to market, that's the most important thing to happen. Improved product quality, because everything is transparent, we know what to do, the quality improves. Increased customer satisfaction, reduced cost of production, reduction in engineering change request. This is an important thing, engineering change request. If there is an engineering change request along the process, then later on, if we have a change in the request after, say, production, then there may be $1 million question, $1 million wastage. If there is a change request in the prototyping, then maybe a $10,000 penalty. If there is a change request during the product development, that is developing the tools, dies, fixture, etc., then maybe $1,000 penalty. If there is a change request during the design, maybe a $100 penalty. So the cost is very less because we are taking all decision together earlier. The change request later on will be less, so the penalty will be less. Reduction in engineering change requests, increase return on investment, increase level of group productivity, and the interdepartmental cooperation increases because we know why the other departments is taking decisions. Reduction in development cycle time, increase in sales, reduction in the life cycle cost, and rationalization, communication improves. There are few pitfalls in the concurrent engineering approach. One is the orbital process. If we don't share the information together, then we'll keep on moving in circles. We'll not move forward. Degradation of turnaround time. So sometime if the information, either the immature information is shared or the information is not shared in the time, then turnaround time will be moving in the again circles, and the circles will be very longer. Concurrent queues. So if you change something later on, then there will be queues in every department. There are advantages, there are disadvantages. So it's something like those who have done lean manufacturing. Lean is very good, but if there is a change request in lean manufacturing, then there is a queues everywhere because we have not taken the extra inventory. So there are advantages and there are disadvantages. So these are the disadvantages if you don't do your work properly. Concurrent conceptual model. This is how a model is developed, which is a PACE model. One of my Indian friends working in the USA, he developed this thing. I forgot to mention his name. Of course, it's a PACE model name defined by him. So everything like concurrent engineering, the heart. So there are prerequisites for concurrent engineering. What is those prerequisites? Organizational leadership should be open to provide the ownership to the team, and there should be a system approach. Then there should be the customer focus. So everybody has to agree that everybody has to work for the satisfaction of the customer, not department, not as a, I'm not working as an engineer, design, a manufacturing engineer, or a service engineer or something. No, everybody will work for customer. Then parallelism will work, cooperation between them, and goal sharing, continuous process improvement. They go to this thing. Then define the goals and program with the economics, time, quality, the result, success and failure. You have to share all. Then let's provide the motivation to the concurrent engineering. It also depends upon the type of company. It also depends upon the view. So this is how the things are done. But more than that, design maturity. So design maturity is important thing. In that moment when a design is complete enough to allow the release of details to the downstream activities. What do you mean by downstream activities? Because these are the various activities we have seen in the beginning slides. So like functional requirements, then design, then product development, then testing, then production. So these are the downstream activities. For this function, all are downstream activities. For this function, these and these are the downstream activities. So design maturity in concurrent that moment when a design is complete enough to allow the release of details in the downstream activities. If I'm designing a project, if I know what type of electric line I'm using, whether it's 12 volt DC or 24 volt DC or 110 AC or 220 volt AC, all those should be defined. You take some time. Once you've taken design maturity, you've taken that I will use 24 volt DC. Then you have to use that only. You can't change later on, otherwise there will be concurrent chaos. So this is how we change. Everybody knows this. There are the change by frequency change and magnitude. When we make something new, there will be frequent changes to that. If you write a research paper, you will make many frequent research changes to the research paper first. As you mature, the number of changes will slowly keep on decreasing. So it happens to design also. Magnitude change. Initially, the magnitude changes will be large. You delete so much thing, add so much thing to your research paper. As research paper mature, the changes will be left only to some few spellings, adding of a line or a word somewhere here and there. So that is magnitude change. So these magnitude and frequency changes also happens in the design maturity assessment. Team composition, how to develop a team. The team has to be qualification, all should be qualified, proper qualified, age, then talent, then experience with similar product, functional area, different functional areas. Then there should be people with the specialized knowledge, like those who have the special software knowledge. Willingness to work in a team is most important. There are individuals who are very bright individuals, but they can't work in teams. And there should be a general attitude of cooperation. So these are same team composition, like this. Generally, there should be 12 to 20 members of a team. If less than 12 may make it a monotonous, and then more than 20 may make it a little bit more. Then characteristics of a team leader. It's a professional competency. The leader should be professional competent. It should be leadership perspective. The leader is one who does not see the small details. I say there is a mistake here, there's a mistake here, there's a list. Leader is one who sees the big picture. What is achieved? All these little details and mistakes can be corrected. And there should be a character, not only character, but character by leading. Show it by leading. Then better communication skills always make a good team. And most important characteristics of a team leader, the inspirational or motivational qualities. A leader is one who can make the others achieve what otherwise they were unable to achieve. Okay, what to develop and how to develop is what is the product development now. The first question for the team is, should a completely new technology be introduced? Or should the current product be refined and tweaked to better please the customer? Or should the product be expanded into variant forms to form comprehensive cover the market? So for example, if Maruti is there, so they should we have the new car altogether, new model, or should the current be refined and tweaked to better please the customer? Should we make some modification in the current model? So for example, Desire, you want to make a model, or should we expand into variant flow? Should we make a different variant? Like they have LX, VX, ZX, etc. Should we make a different variant to take into consideration? Of course, different variant means different cost. So these are the three decisions generally team has to take, and they are called original design, adaptive design, and variant design. As you know, original designs are less, adaptive designs are more, and more are the variant designs which require less innovation. Product development versus product design. So generally there are many time questions. What is difference between product design and product development? Are they same? So product development is the process, is the entire set of activities required to bring a new concept to a state of market readiness. So you have some new idea and bring it to the market readiness. That's the product development. And product design is a part of this, is the set of technical activities within a product development process that work to meet the marketing and business case vision. So these are the technical activities. As we'll discuss what is not in the product development and what is only product design. So first of all, the typical activities in a product thinking, new design thinking are: understand the opportunity, develop a concept, and implement a concept. Understand the opportunity. If you have to improve your design thinking, then understand the opportunity first. Develop a vision. So what is the vision? What we have to achieve by this product? Market opportunity analysis. Do the market opportunity analysis. Then customer need analysis. Find out the need from the customers, whether this is there. Then competitive analysis. See the market, who else is providing the similar products. After this, stop. This is a stop gate approach. After this, stop. If yes, go ahead. Otherwise, stop the product development, development phase. So if you agree that you are happy with this, that's positive, then go ahead, then develop a portfolio, make a functional model of the product, develop the product architecture, and finally find concepts. Concept engineering here means concept generation, concept selection, and concept embodiment. 3 area. Then finally think, yes, should we go ahead or stop here? Then yes, then go ahead, do the embodiment engineering, concept embodiment, do the physical and analytical modeling. See, right now we have not developed product. We are doing only concept up to here. And we will see that I will ask you some question and I will show that directly nobody comes here. Directly people from here, they directly go here. We Indians are very good in giving the solutions, in giving the fundas, but we are very poor in developing the concept. Then physical analytical modeling, after embodiment, design for X. So X can be here design for manufacturing, design for assembly, design for reliability, design for disposability, design for disassembly, design for economics, etc., etc. And finally, you have to see the robust design, that your design when will be developed in the, not in the lab, but in the actual factory environment, which will be different than the lab environment, when the product will work not in the lab, but in the actual condition. Your car which should work as well as in the Rajasthan, Jaisalmer 50 degrees centigrade, as well as in the -50 in the Leh and Ladakh. So they will be the actual working condition. So that will make the product design, robust design. You have to do that robust engineering later on. So these are the 3 concepts. So a little bit different in the reverse engineering. Many times students asked, reverse engineering is also an important concept. So many times I tell that these are the new design. This is the reverse engineering if you are doing, then almost similar steps, but little bit different step. So let's go. Then you take a decision about this technology as go. So it's an important aspect where you are going. So generally technology, and in technology generally have a S curve. It looks like the word S. So if we draw the performance versus time, so it look like this. So in the initial time, performance is good. Then as the time improves, the performance will improve. That technology approaches physical limits. Let's see that. Let's take an example. Let's take the case of lighting system. So initially we have the different lighting system. For example, our incandescent bulb. So light units are candela or luminex. So say this is incandescent bulb, and this will be give a like 50-watt incandescent bulb, give this many luminex. You know, this is performance of the light luminex. What is? Can somebody tell me? What are the units of light? Luminex, na? Or am I wrong? Lumens. Okay. Usha, thank you very much. Lumen. Then came the CFL or your fluorescent tube. So they came somewhere here. There's a lot of difference between lumens of incandescent bulb and they will go like this. They not here, they came here when this was going on. The new innovative people. This is called innovative thinking, new design thinking. And the people who develop, immediately they step and they develop a new technology curve for, say, fluorescent tube. I will discuss this curve later. Then after fluorescent, then came CFL. They started somewhere here, CFL. Oh, no, here. Then came the new walls these days. And there have a new variant of your, what is called these days after CFL? We have LED lighting system. So you see per wattage, the performance of LED is very, very high and the respective time. So what this curve, what happens and what is the innovative and design thinking here is, that in the initial phase, when something new company comes, these are the so-called newer companies, startup type of things. And they take a lot of risk, and there are few companies here. Because they have taken the risk, they have developed something, the performance is very high, everybody will buy this product. And when performance is from this to this, everybody will go for fluorescent tube. And there are only few makers. Those were the market leaders, design thinking. And then many people will start in, because this business will go out, many new people, new companies will come here. And they will do the incremental improvement in the performance. This is incremental. Many people will come here in the market, and there will be incremental performance. And then finally, after some time, physical laws applies, physical limits applies to the system, and there are no further improvements. And these peoples who are here, they are very innovative people. They will leave this thing. They will start thinking of something else. And here only few players will remain, and they will make money only by the scale production. They will do a lot of scaling production. And meanwhile, these people who are here, they think of a new idea, and they came up with a new product here. They make a new quick box quickly with providing a lot of performance improvement, and this keep on repeating. So if your product is somewhere here, don't go for this. Stop your design thinking. Because already the physical, there are of course like few couple of exception to this physical limit. One is about your development of what is in-text develop hardware in your computer. There's only one physical law that had crossed the physical limit, still working. So first you have to find out where is the technology S-curve, what you want to develop. Who should design the product? Team, cross-functional team. A team is defined as a two or more person engaged in a common goal. They should have a common goal. If there are two people working together, but their goals are different, then that's not a team. And more important, all team members should depend upon each other for the success of their own goals. If they individually they can be successful in their own goal, then they will never cooperate with each other. And who have joint accountability for the outcome. Only then we can call that is a team. There is a pride principle in team. That is the purpose. So purpose should be same. There should be respect with each other. There should be individualism. We should respect the individuality of each one. And discussion, there should be frank discussion, heated discussions, but only for the purpose. And there should be excellence. So that's the pride principle of the team. Then another important aspect is the Carnot model after the German scientist. In a product, what is there and what makes you think like a new design engineer? So product, so this is function versus the function in the product versus the satisfaction of the customer. So there are three types of satisfaction. One is the basic needs. This is the basic need. So if you provide the basic needs, customer is neither dissatisfied nor satisfied. If you provide. But if you don't provide, he will be highly dissatisfied. I will come back to this. Then this is the one-dimensional product, means more you provide, more will the customer happy. Less you provide, less will be the customer happy. And the customer always talk about this. Customer does not talk about this. He take this for guaranteed. He only talks about this. And as a design engineer, you should look for this curve. Attractive or delighters. Customer does not know about them. how these needs can be satisfied, how better you can be. So you as a designer, you should always look for this thing. If you get this, customer will be highly delighted. But customer only talk about the one dimensional need because he or she knows about this only. They don't know about this, so they don't talk. They take them for guaranteed that this will be there. For example, you are all young. Otherwise, first in the refrigerators, there used to be you press a button, only then that will be defrost. Your freezer will be full of the ice. Then on the Sunday morning, you just defrost. Then there will be a lot of water coming out. So as a small kid, I still know that Sunday morning we will do early morning, first thing in the morning, defrost, press the defrost. Then after half of 1 hour, we'll have a lot of ice to play with. But now we have automatic defrost. So nobody talks about automatic defrost these days. But if you don't provide automatic defrost, everybody will throw your product out. Now they think of the variable compartments or something else. So this is what generally we say, no, the customer is king. Provide what customer wants to know. The Sony Incorporation boss, he said the customer is not king. Customer does not know what we can provide in the product. That is why Sony is still for so many 70, 80 years, they are the market leader in everything they do. Because this is customer is not the king. Customer does not know what we can provide in the product. Because they always look for this. Okay, this is the Kana model. This is the Akia Morita, is the founder of Sony Incorporation. That say our plan is to lead the public to new products rather than ask them what they want. The public does not know what is possible, what we can do. So this is what we think. There was a very interesting thing which happened sometime. So like I was in a company in Europe that manufactures steel. And the company is as big as our Bhilai steel plant. So we went there. So there is no security. There is no boundary wall to the steel plant. Just to control the lorry, the supply chain, they have just one boomer. That also automatic, that's open. So after visiting, I asked, so you are not worried. You allow everyone inside. Even they give gift if you go inside, particularly the small kids. So that's why you are not worried about. Then he asked me, why, Professor, why should we be worried? I said, somebody will take your secrets. Then he laughed. Then he said, yes, we will be very happy if somebody takes our secret. I was really Zelgito steel plant. You will be very happy. Somebody, yes. What we are doing, what people will see, we are moving ahead now. The person who is taking our secret will always be a step behind us. That's not design thinking. He says that if somebody will take your secret, they will make what we are making today. But what we are making today, we have already started working on the future. So those guys will always be behind us. They will never go in front of us. That is what we want. We want only to be the leader. So that's the purpose here. You should always look for the delighters. Then product function. So when you have to improve your product thinking, new design thinking approach, then you think in a different scientific manner. How to think in a scientific manner in a product design. So earlier they say the product designers, they are born designers. Nothing like born. Everything is created these days. Even we can create the people, human beings, in test tubes. So what about designers? They can easily create it. So product design. So like to think of the smallest, the very simplest product we can think of is the nail cutter. So this is for the nail cutter. What is the function of nail cutter? How to develop a nail cutter? This will give you. So this is the product function. This is black box approach. So this is a black box. Define the function of a product, nail cutter. Nail cutter function is remove excess length on fingernails. remove excess length from the fingernail. That is the product function. Then this black box, we have to think input and output. It's a simple thing. Input has to be in terms of the three things, same three things should be output. What are the three thing input? It has to be material. It has, it has to be energy. It has to be material. It has to be information. What is the energy input? Because there is a law of energy. What is material input? There is a law of conservation of material. And information input, that is what we are doing. We are removing the fingers and finding out whether my fingers looking beautiful or not. That's information. So when we cut the nail cutter, what is the input material? Finger. Nail is my input into the system. Hand, overall hand, I have to move. Second hand, I have to hold the nail cutter. Then debris will come out. And then finally this material, there will be cut nail. My nail will be cut. Hand will be still there in the system. And debris coming out of this. Here debris should not be there. Then what is the energy input? Finger force. I press the finger. That is the finger energy, human energy. And the hand motion, I have to move the hand and then press it, finger energy. What is the output energy? It's a sound energy. When you cut your finger, there is a sound, crack. Then kinetic energy, the fingernails which are cut, they will fly. And if you see in that's important, if your nails are very hard and dry, that is they require more energy to cut. Because whatever energy you input, the same will be output. So if you have this, the sound will be bigger, like you cut for your finger or forehand. Bigger sound means you require more energy and they will fly far off. Because energy can neither be created nor destroyed. So if you require more energy to cut your nail, there will be more sound and more flying of this energy. So that is how we have to think. Are you happy with the nail? No, not happy. Good appearance, I am happy. So this is called a product function, input, output. We may come back to this. Decomposition of function. Then similarly, think of like another simple thing for all engineering graduate is the screw driver. Every basic fundamental of any engineer tool, screwdriver. So what is the objective of screwdriver? Loosen or tighten the screw. You can loosen, you can tighten the screw. So this we have developed it for a like power screwdriver. But it can still work with if power is not there, it can still work with the hand. So then we have to think of power supply system. Then we think the work manually. If there is no power cut, in India it happens. Then you should be use different bits. Different bits mean the different head. It's not only it's an expensive thing, so we just can't have one type of a screwdriver screwing. So if there are different type of screw heads, we should have the bits so that we can change the bit and we can have the screw tighten or loosen the different type of screws. Then apply the torque, you have to, and they should be feel comfortable. So apply the torque. Which one should I do? I'll take this. Okay, power supply. In the power supply, you need huge electricity and generate torque. You have to use the electricity. Power supply. This is design thinking. Power, to give a power output, you have to use electricity. You should know how to use the electricity. For use electricity, you have to supply the electricity to the screwdriver. Then you have to actuate the electricity. You supply it, but if you don't provide a button on off, then you can't actuate it. If they provide the actuate, then you can't regulate. So you have to provide a regulate to the energy, to the supply, how much I want. So all those things, of course, I can't go into the details of this. There's a beautiful details of this, how to make this. Like apply torque. Apply torque means transmit the torque. First you have to transmit the torque, then rotate the screw and withstand force. because finally if the force is more, it has to free to withstand that. Otherwise that will break. So that is how we do the rotate the solid, any solid. We don't talk about anything now. Okay, there is a QFT methodology, very beautiful methodology, Japanese technique, nothing wonderful than that. If you know this, there are so many research papers in different areas based on the QFT. It is a quality function deployment. Even there are 4 houses of this. Even in the first house, those who know the quality control, they know about house of quality. That is the first house generally. So QFT was originally designed to take voice of the customer and translate it into a. Oh, somebody's mic is on. Raj, Hotel. Can you? Hello. Can you mute your mic? Raj, Bharat, our hotel. Hello. Thank you. Thank you very much. It happens.
I'm sorry.
Oh, okay, all right. So there are 4 phases: product planning, part subsystem, process planning, and production planning. Just let me see. Okay, no, I don't have. So let me go. So it starts with like, this is your first house. And this one, product planning. Here we take input as the customer need, what customer wants in the language of customer. Then convert them into technical requirements. To each customer need, we convert them into technical requirements. What is the technical requirement for this? Then in the second house, these technical requirements are the input here. And we convert them into the sub-part need, part classification. What is required in the part? Then we take this part as the input need and convert that into process. What is the customer requirement? Process requirement. Then finally, in the 5th house, products planning, we take the quality needs and convert into the quality control. You know what happens to this? That is called the transparency of the system. So you know from the quality control in the process, everything can be defined why we are doing everywhere in the factory to these customer needs. So that is the transparency. Everything in the company can be defined in terms of this is to fulfill this customer need. That is the advantages of quality QFD, quality function deployment. So generally we talk about the first house, known as the house of quality HOQ. That is how to convert the for the need of the time, we can be a little bit fast. Let me go directly. So house of quality looks like a house finally, like this. So it have a look of a roof, etc. This is called house. So it has 2 portions. One is the horizontal portion, which is on your screen. This is known as the customer portion. Here, whatever the customer wants, put that. So first go to the customer. Of course, there are various methods to go to the customer and to take the customer requirement. So get the voice of the customer, different voice of the customer. So depending upon the complexity of the product, if the product is very simple, if you want to make a cup, for this cup, it may be a few things. But if you want to make a simple coffee cup with a LED, like barista, it may be a little bit more. And if you have to make the house of quality for something called your car, then there may be thousands of customer needs. So then we divide them into different sub areas. These are customer needs for colors, customer need for aerodynamic, aesthetic needs, or suspension needs, like this. So there are various subdivisions here. We keep on subdividing the things like number 1, number 2, number 3, 1.1, 1.2. Each area has a definition. Then each customer need should have a performance rating on a scale of 1 to 9 or 1 to 10, generally 1 to 9. So all needs can't be equally important. Simply saying everything is very important, 9999, no, can't be. So all customer needs should be defined 9, 6, 3, 2, 1, something, something. Then go to the customer, find out your competitors. Same thing is coming here like. Go to your competitors, take the product competitor X, Y, Z, maybe yourself. Then ask the ranking of 1 to 5, which competitor and you satisfy this customer need on what scale. Got your point? First ask the customer need, what you require. Then ask them, okay, this is the need. For example, disposable coffee mug. Sasikant? डिस्पोजेबल कप पड़ेंगे दे दे लेके आने चाहिए बाकी लेके है ना then ask them how's better this is the most important thing. If you are unable to satisfy if you are unable to identify the customer need properly, everything you will be doing wrong. There is a good case study in the USA about a toaster. I hope many of you know about toaster. So generally when you go to the hotels, you put your bread into this, press it, so it will heat it up. So there's a company which had almost 70% market in USA. I forget the name of the company. They developed a new toaster, and the new toaster was a flop, big flop. They lose the market to other. So the company immediately made a committee to identify what happened. Then they went to the customer, those from where they have taken the customer need. In general, in India, it is free. Otherwise, the customer are paid for customer need identification. You go and get some performer field, then you have to pay them the money. So they went there, pay them again. Then I asked, ma'am, we asked you so beautifully, then you told that I want this, but you are not buying the new customer. Then the lady said, no, this is very lousy, new product. Why, ma'am, why this is lousy? Because this is now it's so heavy. I can't pick it up. I have to clean my kitchen. I can't pick it up. It's so heavy. Why you made it so heavy? Do I look like a bodybuilder? They say, ma'am, you yourself told it should be stable. It falls while you are cleaning. Then lady said, yes, I said it falls. Then does not mean you make heavy that I can't even pick it up. What the customer wanted is stability. Some heavy weight at the bottom, not the heavy product. So if you pick up the wrong customer needs, you are doing everything wrong throughout the factory and you are likely to fail. So once this is out, this is also known as the wants and need in our language. This is how customer rates the different thing. Then finally this, okay, this is another simple product, no? Coffee, disposable coffee mug. So we'll take this case study. The vertical portion is now engineer portion. And you should not do engineering in the horizontal portion. You just note down what is done. The horizontal vertical portion is the engineer. So that's you convert this customer need into technical requirement. Okay. So let me see that I have. Oh. So okay, I have a customer need. This is disposal cup. Anybody wants to be customer? Quickly can tell me 2 needs which you want to improve. Yes. Okay, I myself sturdy. Oh, so tell something, but I can sturdy. So when you are Usha, when you are customer na, you don't speak language of engineer. है ना? For example, if I am the customer, I go somewhere. Now we don't travel too much. Earlier, you hold it like this and it's hot. Oh, है ना? So we generally held it like this.
Yeah, true.
True. Okay. I have a lot of. We hold it like this. We can't hold it like this because it's very hot. So what is the customer need? It is hot. Or the should not burn the hands. Should not burn the hands when holding it. See, don't change the customer language because these will give you some time later on your ideas. If you change the language, that sometimes the intention may be changed. So whatever customer says, mostly you add those things. Anything? So like 1 month back, I was in a meeting in Jaipur and somebody was just give a tea and just passing through and then it leaked. My whole suit was destroyed. So it should be leak proof. It should be leak proof, should not leak. Let's take only two. That much is the time we have, 20 minutes we have. Okay. So now tell me, what will be the technical requirement for this? My material, my hand should not burn when I held it. And there is one more. It should not, the tea should not become cold quickly. No, that is the thing these days. If we held earlier, we can't hold it because it hot. So we have to keep it some time. After then, when we hold it, the tea is also cold. So there is no taste. So let's take three things. So what is the technical requirement to convert the hand should not burn when I held it? So what is the technical requirement for this? Now is the design engineer. Quickly, please. There are 50 people, except Usha, nobody is speaking. So Usha Raghavan says choice of material. All other 49 are speaking, sleeping. Something, don't be afraid of saying something wrong. What is there? Your thought process will become clear. Say something. Nobody? So material? Make it thermocol? Yes? So generally when I ask in the class, the students say, sir, make thermocol. Sir, increase the thickness of the, increase thickness. Thickness of the material, okay, now we are coming insulation, insulate, okay, good, something is coming out. So now these technical or design requirement should not be solution to the problem. They should be global in nature, they should be measurable, and they can be increased and decreased. Three requirements: global in nature, they should not be a particular solution, they should be measurable, and we can increase them, decrease them. Now tell, what is this? So you say insulate, it is a solution. You have tried a solution. Indians are good at solutions. I don't want a solution here. Solution will be done later on after product design. Last step of the concept embodiment. That is why we are not innovative in design thinking. Our thinking is not design because we directly come to the solution. If a problem, if there is a question and there is a solution you tell, so there is a one way, one solution. You can at the most tell two solutions. That's it. And think, there is a problem And you can develop a concept, 3 concept, or say, and each concept can be implemented in 3 ways. So how many new ideas you will have? 9 ideas. Instead of having 3 solutions, if you have 3 concepts, you have the 9 ideas. That makes you innovative. So don't provide solution to the problem that it's when I hold it, it's hot. You have to find out a global, measurable, and changeable, actionable requirement. And the insulation is a material, size can be increased. This is also a solution, Usha. So what is the requirement is the temperature at hand. This is the technical requirement in the product. Temperature at hand means when I touch it, what is the temperature of my hand? Temperature at hand. When I feel it, what is the temperature at hand? Is this global? It does not depend upon any solution. Is this measurable? Temperature is measurable. Yes. Can you increase the temperature? Can you decrease the temperature? Yes, both way. It is not solution. Temperature at hand, you can have various methods to change. So technical requirement is the temperature at hand, not insulation. They are solutions. Please don't provide solutions. They will be at the last embodiment, I told you. 9th step. So temperature at hand. And you know what should be the temperature at hand? So there you have to put here the values. What should be the temperature at hand? So then you go to ergonomic textbook. Then you have to study like, okay, this is made for adults. Tea is taken by adults when they travel, and the comfortable temperature at hand is this degree. So you put it here. It should not leak. Leak proof means leak can be because of porosity. Find out the porosity here. It's a measurable porosity. Yes. It can change its porosity. You can increase the porosity. You can decrease the porosity. Yes. My coffee should, my tea should stay hot for a longer time. Then the loss of temperature. So the technical requirement will be the loss of temperature per unit time, which is measurable. Yes. Which does not depend upon any solution. Yes. You can increase the temperature loss per unit time. You can decrease it by, say, insulating. So these are the technical requirements. The most challenging is this technical requirement identification. So once you find the technical requirement for all, how? Then you have to find out the relationship, another important aspect. This is another big problem. So like we have temperature at hand, then porosity, then we have, what was that? Loss of temperature per unit time. Okay. Then we have the requirement should not hand, and the third requirement was my tea should stay hot longer. So this relationship, what is the relationship between this and this? So for the time being, because of the shortage of time, I'm not going to detail of this. If you do this, how you have to do this? Generally, if you do from this can be work on this. Yes, there is a relationship we put somewhere like this double dotted and this strong correlation, medium and moderate. Moderate, strong, moderate, and low. So there should be strong correlation somewhere. So if you start from here, na, so there will be something here. Ye bhi hota hai, ye bhi hota hai, ye bhi hota hai. No, don't do this. You have to ask the other way around. You have to fill the relationship matrix like working on this downward. Should I work on the porosity to improve this customer need? Yes or no? Should I work on this to improve this? Should I work on this to improve this? That way, you have to fill it from top to bottom, vertically, not horizontally. If you fill horizontally, everything will be messed up. So fill vertically and see that always there is a strong relationship in one of the horizontal line. If there is not one strong relationship, that means some of the customer needs will not be satisfied. Your customer won't be happy. So to do that, what you can do, either you can have another variant. For I can give an example. For example, like a bike, motorcycle. So generally demand is that the pickup should be very good, and I can zoom quickly ahead of the others at the red light. At the same time, the requirement is that the mileage should be kilometer per liter should be very large, should be 120. These are the two contradictory things you will not have in the same product. So you have to have the different variant for that. One for poor people like me who wants more mileage, other for rich people like you who wants to zoom. So different variants will be there. So that says how. Then you fix the goals or target. Fix like temperature and ergonomically we find okay 40 degrees centigrade, 50 degrees centigrade, 60 degrees centigrade is the target value. Porosity should be this much. Loss of air should be this much. Now it's another beautiful thing in this house. Then you have asked him here. Many times I fill up in my class asking students, design engineering master students, fill up. Then you have already 453 here, 4235. Then there is a mismatch between this and this. If you don't apply your mind and you fill anything here, then you will find out the customer saying the Y is very good, you are not good. And when we are, this also we are doing for the different customers, same customer here, X1, X1, Y, X1, Y1, Y2, this. So there is a contradiction between what customer says here and what you got here. Customer says this Nescafe model is the best at temperature in hand. Okay. And when I found the temperature at hand, I found that this is not so. There is another model, Z, which is better than this. That means something is wrong. Where either this is wrong or your this is wrong or this is wrong. Definitely something is wrong. If this and this does not match, if this and this does not match. So you get an early idea if you do your work, there's something is wrong somewhere. How to find out this temperature at hand? That generally you have to buy the competitor's product and do the experiments in the lab. Or you can get the brochure of the competitors and can get the values from the brochure. So let's stop it. Then it's not that easy. You know? Then these are the relations here. So like if you decrease the, for example, this is the temperature at hand and this is the heat loss per unit time. There is a correlation between these two. Sometimes they can support each other strongly. Sometimes they can contradict each other. If you increase one, the other will decrease. So life is not as easy as that. But that's how beautiful it gives a roof with a cluster. You know everything. So this is how the first house of quality HOQ is generally known as concept engineering. So Dr. Arthur, we have to stop at 10 minutes more, right?
Yes, sir.
Okay. The concept generation, concept selection, concept embodiment. So we already had the design. Hello, can you hear me?
Yes, sir.
Okay, I lost since I will lost connection. So Russians, they study the patents, and they found to their surprise that everything in the patents can be divided into 40 fundamentals. That's engineering, mechanical engineering, design engineering, everything in all the patents, of millions of patents they studied, and they find everything can be divided into 40 concepts. That's it. Though a lot of research papers are there on the tips. Tips is the English name, trees is the Russian name. Please go through this. I'm not going into this. There are simple fundamentals rules they have developed. How from concept, what are the concepts which can be developed? Then there are inversions, then there are axiometric principles. Axiometric principles are like uh, axiomatics, like there are laws, fundamental laws, law of conservation of energy, law of conservation of mass. They are always true. Then axiomatic, they are not law, we can't prove them axiomatic, but we believe them because there is no counter argument. There is no other counter argument. There is no proof against it. So we believe them. We can't provide them the proof like theorem, but axioms are something there is no counter proof as yet. They are not proved wrong by anybody else as of today. That is why we believe them. So that is called axiomatic principle. Very beautiful principle, one of the axiomatic principles. Then brainstorming methods of concept generation. They developed like in minimum 40-45 minutes of brainstorming. They developed a good number of this. Then there are memory maps, very beautiful memory maps we have done recently for sustainable engineering. Then 6-3 like memory maps. Okay, memory maps. One of the memory maps, old memory maps which I saw, maybe 40 years old memory map. That is for golf ball. And it says like golf balls were very expensive. I don't know now. So golf balls are very expensive earlier. And you hit the golf ball and it goes somewhere. Generally, they are lost. So people are very studying like how to find them. So 40-50 years back, somebody thought that you can have a sensor in them so that they pee, or you can have find them. They should emit some material, sound or smell. And people, those ideas, concept were laughable 40 years back. Yes or no? But today you can have a sensor of like 20 cent or 20 rupees, and on your like mobile app, it will sense you where is this ball, where is this sensor line. Yes or no? What was laughable 40 years back is true today, is actionable today. So when you develop the concept, when you generate the concept, there are two parts of brain. One part is evaluative, other part is generative. One half of the brain generate the new ideas, other half evaluate it and kill that idea quickly. So it is said that when you do this concept generation, keep your evaluative brain shut off. Don't use it. Generate the ideas, maybe hanky-fanky, laughable, maybe 20 year, 10 year to 30 year, 100 years, they may not be actionable. Maybe after 200 years, they will be actionable. Just document all the 6-3-5 map is another idea which talk about the teamwork also. Please go through this. I'm not going into this, but they are good action, like concept generation ideas where we work on each other. This 6-3-5 is like the six people. Everybody will get a sheet, paper sheet. Divide that sheet into 4 areas. Everybody, 6 people sitting around. Okay, and like I have some for screwdriver, generate some ideas. So you draw some ideas for a screwdriver. Concept, generate some concept, 3 of them, leave one blank. So they give 30-40 minutes. Then each one will pass this seat to the right person, the person on the right hand side. So the person on the right hand side will get the other seat. One is still blank out of 4 parts. Then you can make modifications in that. You can't delete anything. You can add, you can modify them, you can add, but you can't delete. Keep on delete. Then after some time, again pass to this right. So after 1 hour, your seat will come back to you. And you developed 3 innovative ideas, and all the people, the other 5 in your group, they have added on those 3 innovative ideas. So you have a lot of more ideas. Then you can develop it further. Then this is done 5 times. This is repeated 5 times. Then finally you can have here. So you have 30-35 ideas, good ideas in a reasonable time. So they are concept generation techniques, morphological, action verb analysis. Then concept selection is not so difficult. There are like multi-criteria decision models these days. So from those you can find out the various concepts. Then concept embodiments come the last. And the solution, insulate it, increase thickness, give thermocol, from all those things, increase the height, length of this, so that we can hold it, provide the paper clip on the side. All those things are coming now, concept embodiment, when everything is done. So I taught the last time. So the last class comes the concept embodiment. So this comes this thing, the reverse engineering and product development. What is happening? Sorry. Design for X. So design for X means design for manufacture. So design should be easy to manufacture. You have to see during the design that everything is easy for environment, good for environment, reliability, everything. You can't do later on anything. It has to do during the concept design only. How to design for sustainability. This is one of this person from Bikaner, PhD student did this. That how to design for sustainability. When we design for sustainability, you can have a large number of questions developed out. That is what we thought of. We thought anything in the factory can be divided into 7 types of materials. These are the material, the air you consume or you affect, the water you consume or the water bodies you affect, the infrastructure building you have, the energy you consume, the material you consume, the money you consume, and the people who work on this. And there should be policies, sustainable products, sustainable processes. So for each question, we ask this question ourselves. Does the organization aim to reduce toxic supplementary material consumption? So we are asking out of this material to sustainable policies. So we developed comprehensive policies to improve design. Beforehand, we can tell that before a design goes into the production, before that we should know how sustainable is our design. So thank you very much. 3:45 he told, so it's 3:43. We have 2-3 minutes for question answer. I will be happy to answer your question if you have, or if you have any comment, good or bad, that's also good for me to improve.
Yes, it is requested from the participant side. Please ask any query. Sir is here.
The live example you gave was very nice, sir. Taking an example and then explaining.
Yeah, thank you very much. So it's very interesting. Last semester, master students, because they were not on the campus for the first year.
Yeah.
So I told, okay, I can tell you the question paper. You note down the question paper. So they were very happy. I told the question paper will be design of overhead projector.
Oh.
So design overhead projector, think of the whatever you have done until now. And so in the classroom, I gave the design of a pen.
Oh.
So it was same thing, no? Same question.
Yes.
So because unless you solve it, you Design thinking comes from not from hi-fi, how to build a satellite, how to build this. First, build the pen, pencil, cup, mug, and all those things which are around you. Because you have the knowledge, engineering knowledge, you are a good user of them, you are a good engineer of them. So that's better for learning, basically. Thank you very
So,
much.
and after that, 3D printing also can be done and to see the effect.
Yes, it can be done 3D printing. Of course, little bit like material is a limitations. We have only similar type of materials, PLX or PET. But concept you can see.
Yeah.
That's perfect.
Good session, sir. Thank you.
Thank you very much.
Anybody else from participant want to ask anything to sir? Thank you, sir. This was very informative, a very innovative and nice session. We are getting compliment in the chat box, and sir, we are very thankful to you too for accepting our
So
invitation.
should I stop presenting, Indu?
Yes, sir. Yes, sir. You can.
Madam, can I share something?
Sure, sir.
Yesterday, I was watching a show in Sony Television, Shark Tank, and a young man came from a village from Malegaon, and he showed a wonderful. He had created a machine for his father. His father used to spray insecticide and pesticide on the farm, so it was very heavy for him on the shoulder. So to remove that pain of shoulder, he created a beautiful vehicle in which he can keep that bag of pesticide and he can spray through that. He has made a beautiful at home only. He has made in his farm only. He is just 12th pass, but his engineering acumen was excellent, and it was wonderful to see design thinking from a small village like Malegaon. I just wanted to share that. Thank you, sir.
Okay, good. Oh,
Nice.
there are so many innovators. If you go to Punjab, there are so many innovations.
Yes, definitely.
They are all innovative people. They work with their hand. It's observation. What you require is the good observation. You pick up from observation. You observe it critically. Pick up from one area, apply into the different area.
Yes, sir. Anybody else want to discuss anything? So this was the last session of this 1 week FDP on design thinking. Sir, we are very thankful to you for being expert. And
I'm also thankful for providing the opportunity to interact with so many young people. Of course, they are shy. I don't know why they are shy. Young people, young Indians should not be shy.
yes, so definitely they should not be.
Ask question.
So participants are requested to stay back. We'll be having a valedictory function at 4 o'clock. And sir will be in your need, Kuldeep sir will be in need of your wishes and blessings. So we seek for your presence at 4 o'clock, sir, in the valediction.
Right. So we'll log in back on the same link.
Yeah, the
Yes.
same link will be there, sir.
Okay, perfect. Thank you, Dr. Indu.
Thank you, sir.
Thank you, sir.
Thank
very
you,
much.
everyone. Thank you for hearing me.
Have a nice day, sir.
Thank you.
Participants can stay back and or can join back at 4. And the link for the quiz will be shared in the chat box at the time of valediction, at the end of valediction.
Yeah, Dr. Indu, madam.
Yes, sir.
So, are you providing any feedback link in the chat box now, or we have to
Sir.
provide feedback in ATAL portal only?
Sir, you have to fill feedback form at ATAL portal, and we'll be asking you verbal feedback, or you can provide feedback in chat box also. Otherwise, the formal feedback form is available on ATAL portal. You have to fill
Atal
that.
only. Yeah, yeah.
ATAL
Atal.
portal, sir.
Actual, yeah, yeah. In other FDPs, they have created a Google form for providing
No,
feedback
no,
from
sir.
their end. So
No, sir.
that is what.
We'll
So
be taking your verbal feedback, sir.
okay, okay, no issue, man.
Whenever you
Just
feel
I
that.
wanted to check with you. Any such provision is there?
No, no, sir. We are not
You can
sharing
share
that.
your feedback in the groups also, WhatsApp group also.
Yeah, yeah. That we will do.
Sure, sir.
Thank you.
Any other query from participants?
No, again we will join it for 4 o'clock.
4 o'clock, sir. Yes, sir.
Yeah, yeah. Thank you.
Himanshu ji raised hand. Is there any query? Good afternoon, sir.
Very good afternoon. Very good afternoon.
Good afternoon, sir.
Good afternoon. Good afternoon. Good afternoon, Ranjit ji.
So Sangma sir also joined us. Can we start the session, sir?
Yes, please.
Good afternoon. I welcome chief guest of the valedictory ceremony, Professor K.S. Sangma from BITS Pilani, Dr. J.B. Bhambu, Dr. Manoj Kuri, Mr. Vineet, Mr. Rajendra Singh Shekhawat and all participants in the valediction session of this 1 week ATAL FDP on design thinking. We started on 17 with the first technical session of Professor Akshay Dwivedi ji, and the last session was taken by Professor K.S. Sangma from BITS Pilani. And these 5 days have been passed so quick, and we expect that we have fulfilled whatever participants have expected from us. So before taking feedback from participants, I request Dr. Ranjit Singh Rathore to conclude the FDP.
Thank you, Indu ma'am. Good evening, ladies and gentlemen. I welcome our distinguished chief guest, Professor K.S. Sangwan, sir, in this valedictory function. Heartily welcome to you, sir. Dr. Jayaprakash Bhamu, Principal Engineering College, Bikaner. Welcome you, sir. I welcome Dr. Manoj Kuri, sir, Registrar of our college, Mr. Vineet Kumar, Head of the Department of Mechanical Engineering, and Mr. Rajendra Singh Shekhawat. He is the chairman of this EICT approved 5-day ATAL FDP on design thinking. Welcome you, sir. We have come to we have come to end this ATAL FDP. From last 5 days, we all were together and we have seen so many speakers from the educational fraternity as well as the industrial speaker. So we have been known the different facets of this design thinking. As we learn about this design thinking, we have seen that how this design thinking take part of. So many speakers told us about the empathy factor or humanizing factor, how it really affects our process and how it benefits the end user. So I think that is the value addition for all of us. Just as I was reading about it, I just came to across one nice saying by the Steve Jobs. Design is not just what it looks like or feel like. Design it how it works. So I think that it is a very important message which the design thinking workshop has given us. Now, talking about all the design thinking workshop, as we all are aware that to make this happen, to make this successful, many of our faculty members are responsible for it. This FDP was organized by Mechanical Engineering Department, Engineering College, Bikaner. The entire brain after this FDP, that is crafting the FDP, coordinating with the speakers, managing the organizing team by one of the team member, which have been seen during the last 5 days in FDP, that is Dr. Indu Bhuria. And definitely the other team members, too, from my department as well as from the entire college. Dear participants, if you have any suggestions, if you feel that certain sections may need improved, please let us know. We definitely come with our next FDP will have no flaws absolutely. We don't take much of time. I know you people are tired, but considering this is a beginning, let us bring this design thinking in each of our processes, and whatever we are going, let it benefit our end user. Thank you very much. And thank you very much for showing our faith in Engineering College Bikaner as well as in our design thinking FDP. Thank you so much. Over to Dr. Bhuria.
Thank you, sir. Now I request any of the participants to give feedback on the FDP. I request any of the participants for giving feedback.
Yes, ma'am. I am from Chandigarh University, Dr. Gaurav Kumar Bharti from Electrical Engineering Department. So the workshop was very informative actually. This is the first workshop that I have attended based on the design thinking. So it is very new for me and I understand a lot regarding some designing thinking, how to design and lots of things I have absorbed and your PPT that you have shared, it is very informative for us. So thank you, ma'am. And I also want to thank our coordinator from Chandigarh University, Dr. Kuldeep Rathore, sir. And thank you all.
Any suggestions from participants?
Ma-
Yes, ma'am. The entire
Can I?
program
Yes.
was very nice, and we can have these sort of programs in the future. Myself, Professor Shankar Chatterjee from NSHM Knowledge Campus, Durgapur. It was really an enriching session. See, because we don't know so many things, we can have so many inputs which will help us in our career. And all the resource persons were very informative, and entire thing was a wonderful learning experience for all of us. So I'd request you, ma'am, to have a number of more programs in the future. Thank you very, very much. Thank you.
Uh, can I?
Yes, ma'am. Sure, ma'am.
Yeah, I'm Dr. Usha Raghavan from Maharashtra State, from a Diploma Engineering Institute. Actually, I'm heading the Department of Information Technology. I was very keenly interested in all the sessions, very good sessions. Some of them were really classic. And I'll tell you one thing which is very good about this, and one thing which I was missing. Normally, when we go for such FDPs, there is lot of networking that happens because we come across many colleagues who are working in different parts of the country, and we meet them, we share our experiences, we share. So in such kind of online things, I think that networking part is not happening. That is something I'm missing because of the pandemic. It is, but of course, because of this pandemic only, such kind of knowledge sharing is also happening. So it's a what to call, it's a stalemate situation kind of a thing, where one aspect of it has provided so much of knowledge sharing, but we are not having the networking. I feel that if the organizers can share the email ID and phone numbers of all the participants, it will be a good, so that when we need some anyone for that matter needs some expertise or something, we can contact them.
Sure, ma'am.
And all the sessions were very good. A lot of knowledge sharing and enriching, I would say. Thank you very much for the organizing such a wonderful FDP.
Sure, ma'am. We'll be sharing expert details with you all. And thanks.
Not just the expert details. I'm telling all the members also. In the sense, we don't know who is from where, what is right. If you have the details of all the participants and their email IDs and phone numbers, and share it in the group, I think that will be a great thing.
We'll thought of it, ma'am. Actually, some of the participants may have some objection about this. That, in fact, one of the expert also denied to share his details with other members. So we'll ask
Okay.
if possible. If possible, we'll
No,
be sharing with
it
you.
was just a suggestion from my side.
Sure, ma'am. Sure,
Yeah.
ma'am. We'll discuss, and if possible, we'll definitely be sharing the details with you.
Yeah, thank you. Thank you so much. Yeah.
Thank you, ma'am. Thank you.
May I, ma'am?
May I?
Sure, sir. Prashant, sir. Sure.
The session was really wonderful. I got to know from one of my colleague that this type of session is going on, and I registered myself through ATAL port. I really thank you people who are conducting all these things and changing the, I mean to say that whole India. From a core of my heart, I thank all those experts, especially Dr. Akshay Dwivedi and Professor Kuldeep Singh Sangwan and others also. I hope that I'll get a chance to be with you for future. Thank you very much.
Thank you, sir.
Yeah, may I, madam?
Sure, sir. Sure.
Yeah. I'm Dr. Kishore Kumar, Assistant Professor of MBA from Nalsar University of Law, Hyderabad. So when the moment I wanted to register for FDP, I logged into this ATAL portal, and I was searching for some of the FDP programs. So when I saw this program, design thinking program, immediately I have registered for the same, and I got approval for that. I am fortunate to attend this program for 5 days. So this is one of the important area. So now everyone is talking about, and even the concept has been discussed in various perspectives, like product development perspective, innovative perspective, and even manufacturing perspective. And everywhere this concept can be applied. Now, so as a teacher of management, so even I'm having almost 17 years of experience in teaching MBA students. I never taught this subject to the students, but I had a little idea about this design thinking. But after attending this program for 5 days, so I learned a lot. I gained a lot of knowledge out of each and every session. So today, all the 3 sessions are very nice, right from the morning to last session, Kuldeep sir session. So many cases have been shared by the experts, okay, speakers. So those case studies are also useful for us, and even we can share with our students also whatever the knowledge we gained, and we can discuss the same with our students. So I'm very thankful to you, madam, for organizing such a wonderful FDP program, and I've seen your organization. So how you organized this entire program for 5 days. So I bestow my thanks to Hindu madam and Dr. Ganesh Prajapat and Dr. Ranjit Singh Rathod for keeping us informing all the important information through WhatsApp group. So really it was a very nice FDP program. We look forward for such programs in the future also from your College of Engineering, Bikaner. Thank you very much for giving this opportunity.
Thank
And
you.
I congratulate you for successfully completing this 1 week FDP program on design thinking.
Thank you. Thank
So
you.
I thank your management also.
Thanks. Thank you very much, sir. Thank you for being wonderful participants, wonderful audience. And we'll definitely be coming with new FDPs in next session. As with your kind words, this gives us motivation to work. So thank you very much. Thanks for being wonderful participants. Now, I request Dr. J.P. Bhamu, Principal of Engineering College, Bikaner, for his wishes to us.
Thank you, madam. And I think the success of the program basically depend on the participations and their feedbacks. So I just heard 3, 4 feedbacks from the participants, and I can imagine that the program which were conducted by you and Ranjit Singh Rathodji, it is wonderful. I congratulate the resource persons also that they have given their 100% input in the the delivering of the lectures. That's why the success rate, basically the success depend on the type of the input that has been given, or the type of the lecture that was delivered. So of course that is a daunting task also, because sitting on a remote place and in the online mode, keeping the pace of the delivery, it is little bit difficult. So the task that has been taken by the resource persons, that has been justified by the resource persons, and the feedback which has been given by the participants is the encouraging us and basically motivating us in future also, that we have to take such type of programs which basically benefits a lot to the academia persons, as well as the persons who are from the the industry domain side. So I congratulate Ranjit Singh ji that you have chosen this topic, the design thinking. It is basically new for me also when I heard about this design thinking. And what is this design thinking? I have gone various application of this design thinking, like you see what the TQM total quality management had done in case of the manufacturing. Similarly, this design thinking has done the same thing in this today's scenario in industry 4.0 scenario. So the credit goes to you that you have chosen this particular topic, and I congratulate also the Rajendra Singh Shekhawat ji, who is the chairperson of this FDP. He is a the kind person, and he is basically a motivating force for many faculty members at ECB Engineering College Bikaner. That he many times he persuade the things, motivates the colleagues that you have to do this and that. And I congratulate and I place thanks to the registrar of ECB Engineering College Bikaner, Dr. Manoj Kudi also. And importantly, it is not in the last, but foremost thing is I place my heartfelt thanks to the Honorable Kuldeep Singh Sangwan sir, chief guest of today's function, my mentor of research in the research field. So Charan is first to you, sir, Kuldeep Singh Sangwan sir. I learned a lot from your guidance. Under your guidance, I learned a lot at BITS Pilani. You are my, the supervisor at the time of my research work. So, sir, I am just carrying your legacy in this field and hope that your association, not from my side, but from Engineering College Bikaner side, it will be continue in future also. From these words, I again congratulate all the team members who has contributed directly and indirectly to organize this event in a wonderful way. Thank you. Thank you. Jai Hind, Jai Bharat.
Thank you, sir. Thank you very much. You always been inspiration for us, and our successes are belongs to you, sir. You are the only one who supports us in every way. Thank you very much, sir. Sir, we are fortunate to have Sangwa sir with us, Professor Kuldeep Singh Sangwa. Sir have given us time for an expert lecture. Sir have delivered a wonderful and informative session before this. And we are very thankful to him for accepting our invitation for being chief guest in this ceremony. I again welcome you, sir. And I request you to bless us with your words.
Thank you, Dr. Induburia, for your invitation. First of all, Professor Jayaprakash Bamu, Principal of Engineering College Bikaner, Professor Manoj Kudi. I'm seeing in after more than a decade online, of course, the registrar of the institute, Dr. Ganesh Parjapat, and I don't see the force behind who I gave him tough time, Dr. Ranjit Rathore. He has to call me many times. And every team, the organized team, very good idea. Sorry. I think it's a wonderful idea. I was thinking that why you have this topic, design thinking. And I shared just now before the start of my team. So this time there is a huge market for product design, product development team, and with 30-40 lakh rupees. In BITS Pilani, all non-circuit branch, they are flush with many 2-3 offers with the product design development. So this COVID has given us many problems, no doubt about that. It has given even pain to many of us, which we are silently bearing, but it has also given us some opportunity about the product developments. There are so many things to be developed. and this conflict with China, Taiwan, etc. And that also given an opportunity to think quickly and to develop new products. So this is the apt thing to do, design thinking thing. And this is something which we more share with each other, the more we learn. So I think there's a wonderful idea. The success, like more than 77 people are here still now. So that tells about the success of your organizing team to develop this. I'm sure that each participant at least will have 2-3 ideas. We'll carry back with 2-3 ideas to use them, maybe for your course content, maybe for your course delivery, maybe for development of your organization, or as somebody told me, give an example some time back, that to ease the pain of your nears and dears one. And you don't require a lot of softwares to think, make your thinking design. It's simple, fundamental, the basic laws of law of conservation of mass, law of conservation of energy, and information content to this. So wonderful topic, wonderful participant, so nice participant from all over the India, I can see. And I'm sure the able leadership of Dr. Manoj Kudi and Professor Jayaprakash Bamu will provide more opportunity to the various faculty members to develop more such programs. So thank you very much. And thank you very much for providing me an opportunity to be with the young participant here. Thank you very much.
Thank you very much, sir. Thanks for giving us time. Thank you, sir. Your words means a lot and inspires us a lot, sir. Thank you very much, sir. And finally, I request Manoj Kuri, sir, Registrar of ECB, for vote of thanks.
Thank you, Indu ma'am. Am I audible?
Yes, sir, you're audible with little disturbance.
Indu ma'am, am I audible clearly?
Yes, sir, you're audible, but there's little disturbance there. Yes, sir.
Yeah. Some networking problem is there. I think you can hear me clear.
Yes, sir.
Okay. I will switch off my video and now I will be on audio only. Now it's, I think you can hear me. So, welcome Professor Kuldeep Sangwan, and great to see you, sir, after so many years. Dr. Jayaprakash Bamu, Principal of Engineering College, Bikaner. Dr. Ranjit Singh, organizer of this FDP, Hindu ma'am, and Rajendra Singh Shekhawat. First of all, I would like to thank AICT ATAL Academy, who has provided us opportunity to organize this kind of program. And kudos to Dr. Ranjit Singh Shekhawat, who has come out of his comfort zone. And as Professor Sangwan is saying, that taking this very relevant topic of design thinking. So, I would like to again congratulate you and your team. And by seeing the profile of participants, I can see the diversified background and from all over parts of India. And when they are giving their feedback, I'm sure that they are pretty much satisfied with the knowledge imparted by the experts from NITs and IITs and other renowned institutions. And last not the least, the participants are the key factor to the success of any program. If participants are satisfied, the knowledge imparted by the experts, then the goal of the program is fulfilled. And I was seeing one or two feedback from the participants. Yes, we are lagging in the networking part. And situation is there, we can interact each other on technology and through virtual mode. So that is another aspect of technology. So thank you all for us. Thanks to Professor Kuldeep Sangwan again sparing his valuable time, and thanks to the participants making this program a success. Thank you. Thank you.
Thank you very much, sir. With the permission of Kuldeep, sir, can we conclude this ceremony, sir?
Yes, definitely, Dr. Indu.
Thank you,
Thank
sir.
you very much.
Thank you, sir. I request Ranjit, sir, for sharing the quiz link in the chat box with the participants. So certificate will be provided to them, sir, who have attended 80% of the FDP and will pass in the exam of quiz. So we are sharing the link for the quiz with the participants. And this link will be open for 2 hours. So it will be comfortable for them. The MCQs are there.
Yes, sure, ma'am.
Okay. So with the promise of meeting back again, we are concluding this FDP here. Thank you, sir. Thank you, Bhamu, sir. Thank you, Sangwa, sir. Thank you, Kuri,
Thank
sir,
you, everyone.
for being
Thank
there
you.
for us.
Thank you,
Thank you,
everybody.
sir.
Thank you.
Thank you, sir. Thank you.
Ranjit, sir, I think we can end the meeting as the link is also shared on this WhatsApp group.
Yes, ma'am.
So if we are sharing key, then we'll stay back.
Yes.
No problem. Ranjit, sir, are you sharing key with us? Just
I will
kidding. Just
stop
kidding.
this recordings and then I will left the meeting. Huh?
Yeah, please share the quiz link in WhatsApp group, madam.
It's already been shared there.
Oh, okay, thank you.
No.
The ATAL portal.
I am just stopping the recordings, but there is a
Sir, we have
technical issue in
taken
that. So I went
the